Hey YouTube, welcome back. Today we have a system design episode or video, system design video. We are going to design YouTube. Um, so at the beginning, the interviews of the system design all the time start with a big question like design YouTube. YouTube is a big platform that has like I'm not sure about what I'm going to say, but let's say that it's nearly hundreds of different systems working at the same time with each other. So in any system design interview, the question will be pretty vague, and your responsibility as an interviewee is to ask for clarification questions so you can design what exactly your interviewer wants you to design. So we have just a design on YouTube. So we want to go with the clarification questions. So the clarification questions, it's from 5 to 10 questions. In this one we have about 8 questions. So let's start first. And first, when you want to ask any question, it should be okay, what I'm designing, what is the more important features about YouTube. So if you know YouTube, you just assume that we know YouTube. So I would say that YouTube is a streaming service that we can watch video or upload video to it. So, and if you don't know YouTube, ask your interviewer to tell you what is YouTube. So first of all, we want to ask a question: what are we designing? What are the important features that we are designing specifically? So we will say the features that we want to have the ability to upload the video and watch the video. So this is what we are focusing on. So let's try to ask different questions. So first we could ask a question about what specific clients are we supporting. These two questions you will ask them in any interview, system design interview. Any system design interview will ask these two questions. And for this one, we'll say we're supporting mobile web browser and smart TV. And we have the other one. It's you will ask you will ask in a lot of the questions that have user in it. How many daily active users do we have? How many daily active users do we have? So we have about 5 million, not 30. Okay, we have 5 million daily active users. So let's go about what is the average time spent on the product, how many the average time of each user, and I guess it's 30 minutes or 50 minutes. It's 30 minutes. So we will go with the next question. It will be, do we need to support the international users because we have 5 million? And the answer is yes. And maybe you have maybe last 3 questions. I would say, what would we support a specific video resolution? And we will say actually the system accepts most of the video resolutions and formats. We accept everything. And the other thing, because I'll tell you something, all of these upcoming questions are based on the first 2 questions. Like you should build the questions so that they should be linked to each other. So it should be, is the encrypted required or in the transform required? And this one, of course, it will be yes, but we don't want to assume anything. We want to make sure that we get the clarifications from into our interviewer each time. And we said that any file size requirements for the video or what we should require. For this one, we have max 1 gigabyte. And we said that okay, can we leverage some of the existing cloud infrastructure like Amazon or Google, because just building all of this from scratch is really hard. It's not good practice. And the answer is yes. So from these clarifications questions, we went to the second thing, is requirements. So we said the requirements, we put them as 5 requirements. First of all, we have the ability to upload the video, smooth streaming experience. We have low infrastructure and cost, high availability. The clients support mobile, web browser, and smart TV. And also, if even though you got all of these requirements, ask your interviewer: is this okay? Is this something that I shouldn't design right now? What is the best? What should I do? What shouldn't I do? You should ask for clarifications each time. So from doing the requirements, we want to go with something with our estimation, so we know exactly the size of the things that we're building. So let's say that we have a 5 million daily active users. Each user watch 5 videos per day. 10% of the user upload one video per day, and each line of these ones you just get approval from your interviewer to type this line. Okay, you can just, okay, we have a 5 million, and just you go on. No, you said that, can we assume that we have 5 million daily active users a day, and can we assume that each one you watch 5 videos, and can we assume that 10% of them upload one video per day, things like that. So we have the video leverage is and the video average is, we let's assume it 300. So 5 million multiplied by 10% multiplied by 3 megabytes, it will be 150 terabytes. And the CDN cost of that, we let's say that when because we want a low cost, so let's talk about the costs here. When the cloud CDN servers serves a video, we are actually charged of the data transferred out of the CDN. If we take CDN cloud for front from AWS, for example, for cost estimation, if we said that 100% of the traffic is served from the US, for example, where we have 500 million. Multiplied by 5 videos, multiplied by 3 from 10 gigabyte, and I will say it's multiplied by 0.02 dollars. It will equals $150,000 a day. So you should ask your interviewer this is okay or not. And after that, if your interviewer confirmed all of that, let's go with the second thing. And what will be the second thing? The second thing would be that we will talk about the design of the of the upload and the design of the streaming. So for the streaming, let's talk about the upload. So let's assume that we have a user, and let's put this user. Okay, let's put this user. Let's assume this is a user or a client or whatever it will be, and it's this user, as we said, it's supported by TV and mobile and a web browser. It will send a request, so we will go. Oh, I don't want something. Be white, please. Okay, so let's say that we will have a load balancer here. So this one will be a load balancer, and this load balancer will distribute all of the incoming requests from the client balancer. Will distribute all the incoming requests to the load from the client, and we'll send them to API servers, and this API servers, I guess, will contact with oh, sorry, let's say that I don't want it to be like that. And let's say put another one here. Well, maybe we have like a metadata DB data. So we got the metadata of the video, and maybe if we want to improve the performance, we could have metadata cache, for example, and for example this will be metadata cache, data and cache, and this. And just make this one here, and just make this a little bit like that, and this one like that. Okay, And from the metadata cache, they will connect it with a handler, a completion handler, and we talk about what the completion handler do. But let's just put it right now. Let's assume it's there. Completion handler, and let's just put this completion handler, this, and this completion handler sends the requests, sends data to both of the meta cache and the DB, and this one is connected with a queue, and the queue, it's a completion queue. Let's say that this is a queue, and this queue messages is connected with a transcoding servers, because we need to transcode all of the videos. Transcoding servers, and this transcoding service is connecting to a transcode storage. Transcoded storage, and the transcode storage is connected with our CDN. CDN, and all of that is connected with our a store, which will be our, we'll use a blob store. Let's call it storage or original storage, and make this one directed. So let's talk about what's going on here. So first of all, that we have a user, it's watches YouTube on devices such as the mobile phone and smartphone, or a smart TV, sorry. The load balancers here, the load balancers eventually distribute all of the requests API servers. The API servers serves all users requests, go through API servers, except video streaming, because we upload the video here. This is the upload video flow, not streaming. The metadata DB video, it's the metadata, this one. The metadata DB video are stored in metadata DB. It is shared and replicated to meet performance and high availability requirements. We have also the cache for better performance. Video metadata and user objects are cached. We have something cool, and let's just to go here with the storage, or original storage, and this is a blob storage system, is used to store the original videos, and we and if you know what is a blob storage, is a binary large object, and it's a collection of binary data stored in as a single entity in database. We can use S3 or cloud, Google Cloud. I don't know Google Cloud storage. I don't know the name of Google because I don't use Google that much. We have the storage is connected with the transcoding servers. The video transcoding is also called video encoding. It is the process of converting a video format to other formats, like let's say the MPG, HLS, etc., which provide the best video stream possible for different devices and bandwidth the capabilities. We have here the transcode storage. The transcode storage is a blob storage also that stores transcoded video files. And we have the CDN, and the CDN videos are cached in the CDN. When you click the play button, a video is streamed from the CDN. Let's go to the competition queue. And the competition queue, it is a message queue that stores information about videos, transcoding competition events. Competition handler, this is the competition handler that we have here. This is consists of a list of workers that pull event data from the completion queue and update metadata cache and database. So this is how the upload flow works. So I guess the right now we finished the upload flow, and I guess it's a good idea to talk about uh, uh, um, how to talk about sorry how to talk how we stream this one. So the streaming, it's quite similar. So it's, let's just assume that we have everything here, and we have everything here, and we have it's quite similar. So let's just talk about the streaming flow, because it's quite similar. It's easier also from the upload flow. So the streaming will be also have the user. Let's put the user like that so we don't interrupt with others. So we have the user, and the user will have oh yeah, the user will have will connect with a load balancer, and the load balancer will ask the API servers, and the API servers will connect the meta data DB, and also let's have this one. And we will connect also the metadata cache, and this is basically, and the metadata DB and the cache, they are connected, as you can see. Also, they are connected with the competition handler, and they are connected with the queue, and the queue is connected with the transcoded servers, and the transcoded storage coding with the CDN. So they pull everything from the CDN. But this is a short jump for you. So for here in the streaming video, so whenever we watch a video on YouTube, it's usually starts streaming immediately for us, and we don't want to wait at all. So we want a pretty low latency, and we can't wait until the whole video is uploaded to just watch it. So so what we could do is that while streaming, like, downloading means the whole video is copied into your device and you start watching it, but this takes a lot of time. And if you can see something, that when you watch a video, when you just click on this video, you watch it immediately. So when we watch the stream video, the client loads a little bit of the data at the time, so we just load a small fraction of the video at the time, and we will talk about how we can do that, why we can do that. We use something called a drag, and we just talk about what is a drag, or DARG. Or dark. What do you mean, drag? Not drag, dag. Sorry, drag, dag. Directed acyclic graph, and I will talk this in a bit. So we download the video in small portions, and before we discuss the video streaming flow here, we also wanna look at important concept of the streaming protocol. This is a standardized way to control data transform from video streaming, popular streaming protocols. And we have maybe some protocols like talk about them. Let's talk about them. For example, MPEG slash dash, and we have and this one MPG stands for Moving Picture Experts Group, and dash stands for Dynamic Adaptive Streaming over HTTP. We have other one which will be Apple HLS, and the Apple HL stands for HTTP live streaming. We have also Microsoft Smooth Streaming. We have Adobe HTTP Dynamic Streaming also. So we don't need to fully understand all of that or even remember those streaming protocol, but this is something for you to just know. And you don't even have to know the names of them, as they are pretty low level design details that require specific domain knowledge. However, the important thing here is that we should understand that the different streaming protocols support different videos encoding and playback players. When we design a video streaming service, we have to choose the right streaming protocol to support our use cases. To learn more about that, I could build a video specifically for that. However, just put this into consideration with your interviewer. Most of the time, it we will you will he will tell you no, we don't need that, but just you should mention it. So we have the video streaming is that basically the client will connect with the load balancer and with the API service, and we just connect with the metadata, and after that we connect with the DB. Um, with the DB with the CDN, sorry, with the connector with the CDN. So before I go with the in details, that I should talk about how we storage the video upload, because it's quite important. Because if we said something that about the video storage, so the video are uploaded to the original storage. First of all, we upload the video in the original storage. The second thing, let's talk about the transcoding. The transcoding servers fetch the videos from the original storage and start transcoding them. When the transcoding is completed, the following two steps are happening. First of all, we transcoded videos are sent to transcoded storage, this one, and the transcoded completion events are queued to the message queue, this one. The transcoded videos are distributed to the CDN. We send it directly to the CDN because we're streaming from the CDN. The completion handler contains a bunch of workers that continuously pull event data from the queue. We have the completion handler, this one. The completion handlers update the metadata base and the cache all the time. Update them, and when the video is transcoded is completed, the completion handler update both of them. We have API servers to inform the client that the video is successfully uploaded and it's ready to stream. And this is the flow of the upload. It's important because I guess I didn't mention that, and it's pretty important to mention that. And I guess we should talk about let's talk about deep dive. Let's just talk about the video transcoding. So let's just, I guess I'll need so let's just talk about the video transcoding. So in the video transcoding, it's quite important to know that when we record a specific video, the device usually be like from a phone or like a camera. It gives the video a certain format. So each device that records any videos, it gives it a specific formats. The video must be encoded into compatible bit rates and formats. So the higher the bit rates the higher the bit rates, the better the quality will be. Bit rate is the rate at which bits are processed over time. So you should know that first, and after that we will talk about why we need to do right now. We know that why we need to do the video transcoding, because each video was taken from a specific device. It maybe have a different format. So the process of the format is the video transcoding is important for specific reasons other than getting different formats. First of all, we said that each video, each video has a max of 1 GB. Okay, so one of the things that we should care about why we need to make a video transcoding, that maybe you have a raw video consume a large amount of storage. So for example, that if we have a video that it's 1 hour, and for this video is 60 frame rates, frame rates per second, I guess the amount of this video, I guess it will be 150 gigabyte, or maybe 100 gigabytes, but it will be really more than 1 GB. So the transcoding help us in just make sure that the video is not, it's not over than the specific storage. The other thing that we have many devices and browsers only support certain types of video formats. Like not all of the devices can see any formats. They have a specific formats. So we use a video transcoding to make sure that we cover all of the transcoding for them and the formats. Actually, we want to ensure that the video watch high quality videos while maintaining smooth playback. It is a good idea for us to deliver a high resolution videos to the user who have high network bandwidth, and also we want to support a low resolutions for video for users that have they have low bandwidth. So also maybe I guess that's it. That's why the transcoding is important, and the transcoding the way that we could use the transcoding, there is a lot of different ways, but what is the most famous and most scalable is something called DAG, and you will listen this DAG a lot, and the DAG is short for directed acyclic graph. Okay, and this one, this transcoding, this transcode video is it makes sure that we support multiple things in the same times, and just what we are doing from this one is that we take the video and we just put it into 3 portions: one in the video, and one in the audio, and one in the metadata. For example, if you have, this is the original video from the original storage, and you put it in the 3 steps. First you have the video, the second you have audio, the third you have a metadata, and the video the metadata is just a metadata. The audio we do audio encoding, and we do in the video, we do multiple things in the video because this one is quite hard. So first of all, let's just say that we do inspection. So in the inspection, basically the make sure the video has a good quality and not malformed. We have a video transcoding, and we have thumbnails, and we have maybe we have a watermark if we want. Some creators requires watermarks, so this happened with the videos. And with all of that, we have the symbol of the end results, so the user will watch this one. So let's talk about the video encoding in details. Video encoding, did I put the video encoding in the video encoding? Okay, so we do the video encoding, and the video encoding, it supports the multiple resolutions like 38 360p, 480p, 720p, and etc. So to make sure that based on your network speed, you get specific resolution. And let's talk about the video transcoding for a little bit. So for example, let's just talk about the video transcoding. So the video transcoding is maybe 5 steps. So first of all, we have the pre-processor, processor, and after that we have the DEG schedule. And the preprocessor here is the preprocessor is supported for it's supposed to support the video splitting, because when you upload the video, you can't upload the video as one chunk, or when you watch the video, you can watch it as one chunk. So the video splitting is video. It's used in the video stream. It splits or further splits into small group of picture, and the small group of picture, it's called GOP. And this GOP is a group or a chunk of frames arranged in a specific orders. Each chunk of them is an independently playable units, and this is usually usually a few seconds of length. It's not big thing. And this is this improves the performance and the latency, and this is the preprocessor is doing. And maybe we have a DEG schedule. A DEG schedule. Schedule. And the DEG schedule splits the DEG graph into stages of tasks and puts them in task queue in the resource manager. So for example, let's say that let's take just a small example about the DEG. We have the original video, and in the original video, this is a stage. You have another stage there. This is let's have a stage, and let's call it stage 1, and we have a stage 2. And stage 1, let's say that we have a video. We split it in a video, audio, and metadata. And let's say that we have in the video, we maybe have a video encoding and thumbnail video encoding. I don't know why it went like that. However, and thumbnail. And in the audio, we have audio encoding. This is stage 2. Audio encoding. And as you can see here, the original video splits in 2 stages. Stage 1, video, audio, and metadata. The video file is further split into 2 tasks. We have in the stage 2, we have video encoding and thumbnail. The audio file requires audio encoding and this stage 2. And let's go back to this one. And after the DEG, we'll do something called a resource manager. Source manager. And this resource manager is the resource manager is responsible for managing the efficiency of resource allocations, and maybe after that we have the task workers. After that, sorry, just it's I guess it will be a long video because we have still time. We have a task workers, and the task workers run tasks which are defined in the DEG. For example, we will do like a watermark, encoding, thumbnail, merger, etc. And after that, we have the encoded video. And and the encoded video is the final output. And after that we store, after all of this process, we store in the encoded blob storage. So we have the temporary storage. We store that in the temporary storage, temporary uh, storage. And yeah, that's it. This is the details of updating the video, and this is a lot of details. So of course, I guess in the real system design interview, you will not have to talk all about that. But I'm just, because it's a educational video, I'm getting in a lot of details. But most of the time, after doing these two things, these two graphs, and you just these two designs, and you just talk about them, the interview will be done. But I'm just trying to get into more details because it's an educational video, so you should understand more, or a little bit more. So let's just talk about, maybe let's talk about the some of the optimization. For example, the speed optimization. So if we uploading the video as a whole unit, if, or for example, if we're uploading the video as a whole unit, I guess this will not be an efficient. So if we can split the video into small groups, as we said, that GOP G, just say G. Oh, sorry, I'll just GOP GOP1 and GOP2 and etc. And basically, if we did that, this allows for the fast resample uploads. When the previous upload failed, the job of splitting video file of GOP can be implemented by the client to improve the upload speed. So also we could do maybe if we want to talk about the speed optimization, let's say that we have a users all over the world, and a good way to improve the optimization is that by setting up like a multiple load centers in different areas. So across the global, so people in the United States can upload videos to the North America and to the North of America upload center, and people in China can upload videos to the Asian upload center. So by this one we can achieve that the CDN is catching the results as fast as possible. Maybe we can talk about I guess we could talk about the speed optimization and how to achieve the low latency. And achieving the low latency requires a lot of efforts, and a good way to optimize this one is that we can build a loosely coupled system and enable high parallelism. So our design will need modifications to achieve a high parallelism. So let's us think about that. So we could store in the CDN, and so for example, let's just talk about this one, that maybe we have to make sure that we improve the speed. So we have the original storage, and this original storage will have will go to a download module, and the download module will go to encoding module, and this is our system, how the system works. And the encoding module will go to an upload module, and the upload module will go in encoding storage, and I guess after that we'll go to the CDN. And to make the system more loosely, we should work with message queues, I guess. So how the system will work will look like if we work with the message queue, that everything will be exactly the same. However, each one of the step, instead of just handling the tasks to the next one, it will send it to a message queue. Message queue, and the message queue will send it to the next, and once this one finished, it will send to a message queue. Let's call it just queue, so it will be easier to type. And no, queue, this one is not. And the message queue will send it to this one, and this one was finished, it will send its results to the message queue, and it will send it to the upload, and it will be so on so forth, like that. And before, if you look at the two things, before the message queue is introduced, the encoding module must wait for the output of the download module. After the message queue that we added, the encoding module does not need to wait for the output of the download at all. If there are events in the message queue, the encoding module will execute them in parallel. So I guess maybe we could talk about what, maybe you could talk about a safety, maybe you could talk about error handling, but I guess this video is getting too much right now, and I guess it will be quite too much to talk all about all of that. So that's it for this video. I hope my solution was quite good. I hope my video was quite good. If you like my content, make sure to subscribe and hit the notification bell so you never miss a video, and see you in future system design or problem solving.